Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Nur Adi Hamka and my matrix number is AN200004. So I will present about the introduction. A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes a processor, memory, and input or output peripherals on a single chip. Microcontroller is embedded inside a system to control a singular function in a specific device. It does this by interpreting data it receives from its input-output peripherals using its central processor. The temporary information that the microcontroller receives is stored in its data memory, where the processor accesses it and uses instructions stored in its program memory to apply the incoming data. A software interrupt is caused by an exceptional condition or a special instruction in the instruction set which causes an interrupt when it is executed by the processor. For example, if the processor arithmetic logic unit runs a command to divide a number by 0 to cause a divide by 0 exception, thus causing the computer to abandon the calculation or display an error message. Software interrupt instruction work like subroutine calls. An interrupt is like a keeper. If one needs a service, he goes to him and apprises him of his need. In case of interrupts, when the flags or signal are received, they notify the controller that needed to service. That's all. Thank you.
Good morning. I will continue the division of tasks. My name is Bongsilie, which is handle the report and the circuit and presentation. Lukman and Hamjir is the main program coding and the flowchart. Natasha and Fatima is handling the ISR slide and presentation, while the audio is handling the slide and presentation. The next is project description. In this microprocessor and microcontroller project, we are required to design a multi-function microcontroller system. The multi-function microcontroller system was designed with the Proteus X. The programming code of the microcontroller is coding at MPLAB IDE. After doing the design of circuit of multi-function microcontroller at Proteus, the programming which saved as text file will run at the PIC 16FX77A. In the Proteus, there was the two programs that we need to develop, which are the main program and the interrupt service routine ISR program. The main program working principle is RB01 to RB1 as the output and RB2 to RB3 as the input. All the bit number output will be shown at the port C with the BCD 7-segment display. The interrupt service routine working principle is RB4 to RB7 as interrupt button. The output of LED all show as port D, RD0 to RD7. Next, I will pass to the next presenter. Thank you.
tekan semua button je kan? Lepas tu dah habis kan? Okay, stop.
Okay, so I'm going to demonstrate our first simulation. That is the main program. When we first run the program, the number it shown will be number 02. That is our group number. When the first button is pressed, it will show number 27. When the second button is pressed, it will show number 56. When the third button is pressed, it will show number 27, 56, and 69. And when the fourth button is pressed, it will show number 78. That's it for the main program. Now I'm going to demonstrate our second part of the program, that is the ISR. So when the program is first run, it will show number 02 just like the main program. And when all of the buttons is pressed, the LEDs will light up except for LED 0 and LED 2. When the first button is pressed, it will show 27. Second button will show 56. The third button will show 69, and the fourth button will show 56, like the second button. I think that's all for the demonstration. So I'm going to present about our flowchart. This part is the setup part, means that this is where we are declaring the value and all. And the next part is this part, that is the place where the program took parts. That is the bank cell port B. It will move value 2 to W and at port C, and then it is also the client port D value. And then it will clear port B, and it will clear port B. At port B0, it will move value 0 to work, and for the port B2, it will move value 1 to work, or it will or exclusive for work with a value 1. And then for the status Z, it will go to row 2, or it will move value 0 to work. It's basically this one. So after that, at port B3, it will move value 1 to work, and the same as the one I told earlier, the 0LW1. And then at this status Z, it will go to column 2, and it will move value 0 to work, the same as earlier for the port B3. And for the status Z, it will go to column 1, and it will also move value 0 to work. At port B3, just as the same. And then the status Z, it will go to the row 2. Next, this one is the at port D1. It will move value set 1 at work, and then into the port C, and they will call delay. The same will happen at the set 2 and set 3. But for the set 4, after it moves the value, it will go to column 1, and then it will go to loop. Now, this part is where the part where the ISR begin. At the Baxter port B, at the port B4, it will go to output 1, where at output 1, in the output 1, it will go to port 4 and then port 5, and then call delay. And then will happen again, it's port 4 and 5, and then call delay, port D4, 5, delay, and port D4 and 5, and then it will go to rest time. At the port B5, it will go to output 2, where the same thing will happen, but instead of just port D4 and port D5, this one at output 2, it will it will happen with port D4, 5 and 3. For the port D6, it will go to output 3 where the same thing will happen also, except this one we will use the port D4, 5, 3 and 6. And for the port B7, it will go to output 4 where it will also do the same thing by using the port D4, 5, 3, 6 and 7. And after all the progress has been done and all of the output 1, 2, 3 and 4 is at the left side, it will end. And that's all explanation from me about flowchart. Thank you.